Shekhar Saini from Government Polytechnic College Sikar. Today in this lecture, we will discuss about the various losses in DC generator. Various losses in DC generator. The various losses in DC generator can be divided into three parts. First is copper losses. Second is magnetic losses. And third is mechanical losses. Mechanical losses. Now, we will discuss each of these losses one by one. So, first taking copper loss. Copper losses. The copper loss is also known as I square R loss, and this loss is due to flow of current in resistance of winding. Due to resistance of winding. And first, copper loss consists of flow of current in armature winding. And when armature current flows in armature winding, then copper loss IA square RA will take place in armature winding, where IA is armature current and RA is resistance of armature winding. And this loss is due to resistance of armature winding. Second is due to series field winding. And copper loss in a series field winding is given by ISC square into RSC, where ISC is current in a series field winding and RSC is resistance of series field winding. Next, shunt field copper loss. Shunt field copper loss, and this is equal to ISH square into RSH. Here, ISH is current in shunt field winding and RSH is resistance of shunt field winding. Next is copper loss due to brush contact resistance. In DC machines, brushes are mounted on the commutator and there is some contact resistance. And when current flow from brushes to commutator or from commutator to brushes, then some I square R loss will take place due to brush contact resistance. So, loss due to brush contact resistance. Brush contact resistance. So, resistance in armature winding, armature copper loss in armature winding, copper loss in series field winding, copper loss in shunt field winding, and copper loss due to brush contact resistance. These constitute total copper loss in DC generator. Second part of losses is magnetic losses. Magnetic losses. And magnetic loss in DC generator consists of two parts. Hysteresis loss. And eddy current loss. Eddy current loss. Now first we will take hysteresis loss. In DC generator, hysteresis loss is due to a reversal of magnetization of armature core. Hysteresis loss is due to reversal of magnetization of armature core, and this hysteresis loss is represented by WH, and its value is given by what? Where BM is maximum value of flux density. Maximum value of flux density. In Weber per meter square. In Weber per meter square or Tesla. F is frequency of reversal. Frequency of reversal. V is volume of core. Volume of core. And T is proportionality constant. Is proportionality constant. So the value of hysteresis loss in DC generator depends upon maximum value of flux density, frequency of reversal, and volume of core. Next magnetic loss is eddy current loss. Eddy current loss. In DC generator, eddy current loss is represented by WE, and its value is given by value of eddy current loss is given by Q B maximum K square into F square into T square. What? Where BM is maximum value of flux density. In Weber per meter square or Tesla. F is frequency of eddy current. And T is thickness of laminations. Thickness of laminations. Q is proportionality constant. Q is proportionality constant, and WB is eddy current loss. So, when the armature core rotates in the magnetic field produced by field poles, then an EMF is induced in the armature core, and this induced EMF circulates current in armature core, and this current is called eddy current. Eddy current. And when the eddy current flows in armature core, then due to resistance of armature core, there is eddy current loss. Next is third part of the losses is mechanical losses. Third part of the losses is mechanical loss. And in DC generator, mechanical loss consists of windage loss and friction loss. First, windage loss. Windage loss. When the rotates in the air, then air opposes the rotation of rotor, and because of this, there is some power loss, that is called windage loss. Windage loss. So windage loss is due to rotation of rotor in air. Second part of mechanical loss is friction loss. Friction loss. In DC generator, there is friction at bearings. There are some rotating part and some stationary part, and when the rotating part rotates, then there is some friction loss at the brushes and at the bearings. That is called friction loss. So total loss in DC generator is divided into three parts: copper loss, and in DC generator total copper loss consists of copper loss in armature winding, copper loss in series field winding, copper loss in shunt field winding, and copper loss due to brush contact resistance. Second part is magnetic loss. Magnetic loss, and this magnetic loss is also called core loss. Core loss. And in DC generator, the magnetic loss consists of hysteresis loss and eddy current loss. Hysteresis loss and eddy current loss. When the armature core rotates in the magnetic field, then an EMF is induced in the armature core, and this induced EMF circulates current in armature core, that is called eddy current. Now, when the eddy current flows in armature core, then due to some resistance of armature core, there is I square R loss, that is called eddy current loss. And when the armature core rotates in the magnetic field produced by the field winding, then its magnetization changes, and because of that there is some loss, that is called hysteresis loss. Third part of losses is mechanical loss, and the total mechanical loss in DC generator consists of windage loss and friction loss. So these are the various losses in DC generator. Thank you.